Okay, so this is a quick tutorial on how to design a simple PCB using EasyEDA. So what you're going to want to do is log into EasyEDA, make sure that you have signed in appropriately, and we're going to go ahead and start with the EasyEDA Designer to get our circuit put together. So to get started, we're going to open up a new project, and I'm going to call this Hello World Practice, and I'll save that. And that is going to open up this new sheet where I'll be able to design the electronic schematic of my project. Now at this point you sort of need to know what you're going to make. For this practice I'm going to make a simple circuit that consists of an AddTiny85, a little push button, and an LED that will just make it light up. So to do that we need to first start looking for components. To open up our components search box we can hit Shift F and that's going to open up our components library. Now, there's a couple of different ways that we can source components. The first is that if you've joined the CRT 360 Advanced Prototyping group, you should be able to find some components for projects here by accessing the menu on the left-hand side. As we work on various projects throughout the semester, I'll be adding components here that will sort of help you figure out, what things need to go into the circuits that we're building. However, sometimes you can also source components from LCSE, which is a very popular part supplier, or sometimes there's even other components from other suppliers that you can choose. So as you're building your circuits, you may need to look around and get creative with the types of components that you're searching for. So for example, let's say that I was looking for a servo. I could click search here. It would start searching for them. And hopefully we can see that we have some user contributed servos. These are things that have just been made by other people that are using the software. But we even have some that are made in the system. As you're looking at components, there's a few things that you want to be looking for to make sure that it is the right component for you. And so let's say we wanted to do something simple like a 10K resistor. Okay, so if we let it search for that, okay, what you're going to find is there's probably several. You can see here that there's some in our workspace, there's some through LCSC. You can even see user contributed. There's over 1,000 available there. But at the end of the day, what we want to do is make sure that we are choosing one that's going to work for our board and give us a lot of options. So if I click over on this one, you'll see that I actually have two kind of views here. One, I have a kind of traditional resistor view, and this is going to be for our electronic schematic, and that'll be good. And you'll notice that here we have a PCB view, and what we want to do is the layout of this is what's called the footprint, and we want to make sure that that kind of closely resembles what the actual component looks like in real life. So here you can see where the resistor would go, and then these two holes where you would solder it through the board. And so this is a through-hole soldering, or a through-hole component, and that's most of the time what we're going to be using. And so this seems like an okay resistor to use. Let's see if we can find one that wouldn't be so good. Okay, looking at this one, this doesn't really look like a resistor that we would use. It's actually a linear slide. And you can see that this footprint doesn't really look like a traditional resistor. And so we would want to stay away from this one as we're selecting components. So with that in mind, let's go ahead and start placing down our components. We don't want to make any connections yet, just get the components that we're looking for on the board. And so as I mentioned, I want to use an AddTiny85. Okay, so we'll go ahead and search through that. Lots of different options here. We do happen to have one in the CRT 360 library, and so we can access that here. And so again, we can see that this looks like our normal pin schematic for an AddTiny85, and this footprint really closely resembles what we're going to be soldering in place. So we can hit place and just click once to drop it down. And if you need multiple components, you can kind of continue to drop them along the way. We only need one, so I can hit the escape button and go back to just our normal design view. So I'll hit Shift F again. I will need a CR2032 battery. And so we can go ahead and search for that. That's what's going to be powering our AddTiny85. Okay, and once again, we see that we've got one, and this is the battery holder that comes along with it, and that's okay. So we can see that we're going to be putting that into our component as well. So we'll drop it down here. Okay, so we've got our @tiny85, we've got our power supply, but we need a push button and an LED. And we'll also need a 10K resistor for that push button. So let's go ahead and just look for push button, see if we can find something that's going to suit our needs. Okay, we see that we've got this 5mm push button that comes up, and that's really good. That's the most common type that we use, and so we can choose any of these that have this 5mm placement, and we can drop it down there. Let's go ahead and look for a 10K resistor. Now, with most of your assignments, you're going to be working with through-hole components or THT components, and so I want to make sure that we choose the right ones. For some, we will be using surface mount components, but we'll be very specific when we need those. So I'm going to choose this 10K resistor and drop it down. And then last thing that we'll need is an LED. Most commonly, we use 5mm LEDs, and so as you're looking around, that may be the indicator that you look for. That's going to tell you that you've got the right one. Okay, oh, lots of 5mm. Okay, so this one's an RGB LED. That's not really what I'm looking for. That's a little bit too complicated for what I'm doing. So I might choose something like, oh, this red 5mm LED. Okay, and again, I see the common electrical symbol for an LED here, and a footprint that's going to help me match up the physical LED with my PCB. Okay, so I'm going to just drop it here. Now at this point, I've pretty much got all the components that I need. What I want to do now is arrange them in a way to where things are going to be kind of pretty well organized. I'm going to arrange these up in the upper left-hand corner, and I'll show you why. We're going to ultimately kind of shrink down our design board to make things a little bit more organized and tight. But generally what you want to do here is kind of organize components that need to go together in close proximity to each other. Okay, so I know that that resistor is going to pair up with my push button, so I want to make sure that they're relatively close to each other. Okay, now that I've done that, the first thing that I want to do is I want to make sure that all these components have the correct power and ground. To do that, we're going to use what are called net flags, and these are going to help connect our circuit up to power and ground. For power, we're going to use the VCC flag, and so over here next to the battery, I'm going to drop a VCC flag. On the battery, this long line is the positive side, and the short side is the negative side, and so I'm going to put the VCC over there. On the @tiny85, I have the 5-volt connection here, and so I'm going to put that right there. Okay, so I'm going to eventually be connecting them together. For our LED, that's actually going to be powered off of one of the digital pins on the Arduino, so I don't need to add a VCC flag for it just now. On our push button, it does need a VCC, so I'm going to drop it over near pin 1. Okay, so I'm going to hit escape because I'm done placing my VCC flags, but now I need to actually make these connections. To do that, I can use the wiring tool, or I can also hit W. You can kind of see when I hover over the wiring tool how it has W in parentheses. That's the shortcut key. Now, when I'm making a connection, I want to make sure that I see this little black dot when I go to make the connections. If you don't, then it's not actually making a connection. You might just be close, but not fully connecting the components. So I'm going to connect there to there, there to there. And again, I'm looking for that black dot every time I click. Okay, and here I can see that I've attached all those VCCs. Okay, next up we want to make our ground connections. Our ground connection flag is this symbol right here. Okay, and so you can rotate the component by hitting R. Again, just one of the goals of making a schematic is making things very nice and neat and organized and legible. So I added one for my battery, one for the @tiny85. I will need a ground for my LED. And I'll also need a ground for my resistor. Okay, so now I can go through and connect those up. Oops. And if you make a mistake, you can always Control-Z your way out of it. So I had a misplaced wire there that I just backed out of. Okay, so now we're really coming together. We've got a few more connections that we need to make before we'll be able to move on to create our PCB. We had mentioned that we're going to power this LED off of one of the digital pins. I'm going to go ahead and choose digital pin 1, and so I'm going to come off and bring that down to hook up to my LED. Now you do want to be careful. You notice how I had to come over and down. You would want to avoid kind of going over and up. If you did this, you'll notice that there's a little red dot there, and what I've accidentally done is connected the LED to both pins 0 and 1. It's a mistake, so you got to be careful if you're crossing over connection points. Just know you may be making accidental connections that you don't intend to. So I'm going to redo that and come over and down, and now my LED is hooked up to pin 1 so I can make it blink. In terms of our push button circuit, I know that I need to connect this pin across to my resistor, and I'm going to go ahead and put this pin up to our pin number 0, and that's where it's going to get its information. And I'm going to move those labels over just to kind of have a nice clean line. Again, at the end of the day, it's all about just having nice clean lines to make the most legible component that you can. Okay, I'm going to kind of highlight everything and just kind of shift it over, give it a little bit of a margin. And now what I want to do is I want to adjust the size of my overall platform to make sure that everything is nice and tight. To do that, I can click on this, and you notice I can change the width of this. I'm going to change it to, we'll try 350. Oh, that's probably a little bit too much. Let's try 500, looks good. Okay, so kind of makes it a little bit narrower here. I'm going to shorten it up a little bit. Let's try 500. Okay, that's great. And again, I'm just going to select these components and kind of drag them to the center. Okay, I want to title this. I'm going to title it the name of my assignment, which is kind of Hello World Practice, but you should title yours whatever the name of the assignment is. And for company, you can put your name. I'm going to put Hackberry Lab. Okay. Now at this point, we want to save this, so you can hit Command S or Control S, depending on your platform. And we've got a very clean schematic here that is ready to be shared and have a PCB built out of it. We do want to save our work here, though, and so we want to make sure that we're able to export this. So in this particular case, what we can do is we can export this as a PDF, and that will allow us to kind of keep our documentation in our GitHub. And so you'll want to export this PDF and share it as part of the documentation step for the assignment. At this point, we are ready to turn this into a PCB. So let's go ahead and do that. We're going to go up to Design and say Convert to PCB. And it's going to give us this warning saying that there's some unfinished nets. You want to check those first. What this means is that there are some unconnected pins over here. That is intentional, but it's always a good opportunity here to check to make sure that you did actually hook up everything that you meant to. In this particular case, I can see that I didn't want to hook up these pins, and so I can say, no, keep going. I understand that those things aren't connected, and that is intentional. Okay. So at this point, it's going to bring you over to a new PCB. I'm going to cancel out of this because we're going to be making some changes on our own here. So you'll see that it's kind of just thrown your components down, and it's got all these little light blue lines that are connecting things together. These are called rat's nest lines. Ultimately, we're going to be turning these into real copper connections, but we have to kind of get things organized a little bit first. The first thing I want to double check is to make sure that my units are in millimeters. Mils are not millimeters. Mils are thousandths of an inch, and so I want to change my units over here to millimeters. For my grid size, I like to set my grid size to 5 to start off with, and my snap size to start off with about 1. And we'll be changing this a little bit to kind of make things easier to design. One of the very first things we're going to do is get rid of this PCB. We have some very specific constraints on the Bitsy board PCBs that we're going to be working with, so I'm going to select that and hit delete. For our Bitsy board PCBs, we're actually constrained to a 30 by 30 millimeter board. And so when we go to draw that, we're going to hover over our Layers and Objects menu and click on Board Outline. Okay, that's going to let us draw a new board outline that fits the specifications of the assignment. So as I mentioned, we want to make that a 30 by 30 millimeter. And so to make sure that I'm doing it the right way, I'm going to change my grid size to 30. Okay, so now I know that one of these squares is 30 by 30 millimeters. And I can change my snap size to 30 millimeters. And if I come over here to the track tool, this is going to let me draw a new board. And you'll notice that it just snaps into those corners to make sure that my resulting object is exactly 30 millimeters. And so if I click once here, once here, once here, once here, once here, and then right click, okay, it'll complete drawing that square. That's going to be exactly 30 by 30 millimeters. Again, I can change my grid size back to 5 and my snap size back to 1 millimeter. And now we know that everything that we have here needs to fit on this square. Now you might be looking at this and be like, well, that doesn't seem very probable because all these components are quite big and I've got a small square. But one of the things that we're doing for this assignment is we're doing what are called two-layer boards. So that means we actually have a top layer and a bottom layer where we can put our components. And so we can actually stack them. In doing so, we need to be careful about some of the choices that we make. But I think if we're smart, we'll be okay. You'll notice that this kind of biggest component here is our battery. And so one of the things that I'm going to do is I'm going to select that battery and actually change it to the bottom layer. I'm going to have it kind of be on the back of the board. And I'm going to have it kind of pointing up by pushing the R key to rotate it. And so I'm going to place it right there. And I'm going to drag its label kind of just to be right in the center there. So it turned green to let me know that it's on the back side of the board. And what that means now is I can take my @tiny85 and I can put it right in the middle of the coin cell battery because it's on a different side of the board. Okay, if you need to zoom in, you can use your scroll wheel or your mouse pad, depending on what you're using. And so here, again, I'm just kind of shifting my labels to make them a little bit more clear on where things need to go. But I'm going to put my switch here, my LED here, and again, I'm just trying to make things look nice and tight. Now, as you're placing your components, you always need to think about how is this board going to be built. It is possible to arrange these components in such a way to where they wouldn't be solderable. For example, if I placed my @tiny on top of this little connector for the battery, you'll notice it's showing me an X, and it's like, hey, don't do that because those two things can't be connected to each other. That would be a conflict. You also would want to make sure that, in soldering this board, we wouldn't want to solder the coin cell first because then we wouldn't be able to go onto the backside and solder our @tiny85. And so you always kind of think about your order of operations. We would actually solder all of these top components and then go solder on the battery. So as you're making things, just be aware about where you're placing your components, especially if they overlap across the top and bottom, and just think about how you would actually build this in real life. It's a really good exercise in being able to design things that are going to work. Okay. Now it's time to kind of orient our components. So you notice that we've got these rat's nest lines that are kind of crisscrossed. And so one of the things that you can do is rotate your components and see if you can get an orientation to where maybe they don't cross over too much. And so we were kind of able to untangle those rat's nest lines. This will ultimately make it easier to wire up your circuit boards. And so try to make any kind of adjustments as necessary. Now you notice this is kind of moving in kind of some chunky increments, and so I can change my snap size to 0.1 millimeters, and that gives me a lot more fine control over how these are being placed. And so you can play with your snap size kind of as you are working with things to really get kind of some nice control over it. Okay, at this point, things are looking pretty good. I think I'll be able to make this work. And so what I want to do at this point is make all of my connections that are not ground or power connections. Now the way that we can tell that is we can zoom in, and here we can see that that's a ground. This isn't ground, it's a U1_5, and that's okay. Here we see some VCC connections. We're going to leave those alone for now. And we see some other kind of non-power ground. So let's go ahead and make those. I'm going to come to my top layer, okay, and we're going to make a connection. I'm going to start with this one right here. So I'll come to my wiring tool. Okay, and if I click this, you'll notice it begins to want to drag over to make that connection. And that looks pretty good. When you're doing this, you do want to make sure that your routing conflict is set to block. This will make sure that you're not allowed to kind of run through any components that you should avoid. So for example, if I try to come like straight down, it literally like won't let me draw my wire through this connection because that would be a mistake. So it's actually helping me avoid making any kind of mistakes. If for some reason that was turned off, you could actually end up designing a board that wouldn't work in real life, and that would be bad. Okay, so we've got that first connection made. Let's go ahead and do this second connection here. Okay, so I'm going to draw a line from here to here. Now, based on the way that we've kind of laid our components out, it looks like we'll actually be able to complete this circuit with all of the wires on top of the board. But sometimes you do get circuits that are a little bit more complicated, where maybe you need to run a wire from here to here, and it would cross an existing wire, and that wouldn't be too good. If you ever come across that, that's okay, because again, these are two-layer boards, so you can always go to the bottom layer and make those connections as necessary. So while this isn't strictly necessary for this one, you can see that I went to the bottom layer of the board and made this connection, and it shows up in blue. So at this point, I think that I've got all of my components on here that aren't VCC or ground connections, but there's a really easy way to double check this. If I come over to Design Manager and I refresh this nets, we'll see all of these are hooked up, but there's an X on the ground and an X on a VCC. And what this tells me is that all of these are hooked up, but I haven't hooked up my ground or VCC just yet. And that's okay, because I'm going to show you a trick that makes this really easy. I'm going to make sure that I'm on my top layer, and I'm going to go back to my snap size, and I'm going to change it to 5 millimeters just for simplicity's sake. And what I'm going to do is I'm going to turn the entire top layer of this board, except where I maybe have these little wires. I'm going to turn everything into a big copper plane called a power plane, and that's going to automatically connect all of the little power points by just covering the whole top of the board with a piece of copper that's positively charged. So to do that, I'm going to come over to this copper area, okay, and I'm going to choose what I want to fill it up with. So I'm going to say this is power plane, so we'll go to VCC and click OK. And again, I'm going to click, 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 right click, and you can see it's building that copper area. And if we take a look, we can actually see the results of what that happened. So here in VCC, you can see how this red is connecting to that pin now, and that means that it's now connected to the entire board. We can see it connected over here. You'll notice over here, it didn't connect to the pins, these other pins that we hooked up, because this isn't supposed to be hooked up to power. Okay, let's go check over on this connection. You see how you have this whole red that's all positively charged, and this little thin red line is a wire, but you'll notice that they're not connected because they're separated by this little layer of black. Okay, you'll also notice at this point that our ground connections aren't hooked up yet, but that's okay because we can do a ground plane on the back side that's going to hook up all those ground connections for us. So if we go to our bottom layer, and again, we'll do our copper fill. This time we're going to do ground, and because we're working on the bottom layer, we can kind of go right over those same 4 points. So click, 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 right click, okay? And that's going to hook up all of our ground connections for us. So again, we can kind of see the result of that here. You can see the ground connection here. And so if we come back over to the top, we should be in good shape. I'm going to go ahead and save this, but let's just double check those connections. I'm going to pop out the Design Manager again. We're going to right click this, and now you can see we've got 10 out of 10. That means all of our points are hooked up. And that's a good sign. That's one thing you always want to check before you submit boards, because sometimes it gets tricky and you maybe miss one or two. So you don't want to do that. Last thing we're going to do is we're going to look for DRC errors. This is what's called the design rules check. And what this does is just make sure that everything is going to be relatively manufacturable. And it looks like there's 0 design rules errors. And so we're in good shape. Now at this point, there's a few things that we want to do, again, for the purpose of documentation. We're going to go into this 2D view. That's our photo view. And I'm going to take off the grid lines here. And I want to be able to get just a nice image here. If you want, you can have the background be black, or you can have it be white, just whatever your preference is. I'm going to do white. And I'm going to export this as an SVG source, and I'm just going to download this. Okay, so that's going to give me an SVG file that shows me the top of the board. I'll want to rename that top so that it's clear kind of what side of the board this is. And then I'm going to change over here to board side to bottom side, and then I'm going to do the same thing. I'm going to export that as an SVG source to be able to give myself a view of both the top and the bottom. And again, in here, that will allow us to look up in real close to see that all these traces were in fact made. So we can see how that board will look like. And so in terms of documentation, that's what you need to turn out. If just for your own amusement, you kind of want to look at your board in 3D, you can click on the 3D view. And this actually allows you to spin your board around in 3D. And again, this may help you think about, when I go to manufacture this, what order would I solder all of these components in? Because like I said, order can sometimes really matter. So at the end of the day, this is how we will be designing most of our PCBs in this class, and I hope this was helpful. That's it.